the docs chat. And there we go. All right. So yesterday we made the class for oh yeah, marker. Oh, hold on, let me get a marker. Maybe the marker back. Well, actually, I did it. Yes. Oh, that's not a good look. Thank you. Okay. All right. So I'll continue with this part in a bit. So, all right. So yesterday I did we turned the entity class, right? We have entities, right? And then we made a circle, right? That is a child of entity, right? Yeah. So in object-oriented programming, uh, this is class inheritance, right? And hold on, let me just do one quick change here, real quick. Do this, this way. See this go. Make it better. Let's see. It's all right, that's better. That's some code in each one. Yeah. Yeah. So there you go. So we have the entity. This is bigger. So an entity class, and then this give us a circle, right? So what do we get? What things do we get from an entity, right? So we gotta think kind of in the abstract here, okay? So, and it's in a way it's kind of a word game because we're trying to describe many different things, and we try to come up with appropriate names for all these different things. So if you end up doing any physics engineering, like even game development, everyone ends up naming these type of things differently, but they are this thing, okay? So they have an entity, right? And the entity describes things like the position, uh, maybe even the weight too, like the mass of the object. But it does not describe the shape. Okay, so the shape is described after. Okay, because you can do a lot of physics just by having one dot that interacts. For example, all of physics 2, when you get into physics 2, all of physics 2 is basically dots because you're talking about atoms, right? That they are interacting with each other and they have like the I am gonna butcher this. I don't know. I'm butchering all of this, but mainly, okay, the thing that I mainly remember is the magnetic fields between them, right? Why they orbit like around each other and things like that. And they're just dots, and they are attracted to each other for different reasons. Okay, so atom could be just like the entity. It has a weight and it has some amount of physical characteristics to it. Okay, now the shape comes in after. Okay, but we're going to be working mostly in like this part because this is way more abstracted, right? So we're going to try to work on this, but we still need this, okay? So in our current model, right, we define the entity as like a point in space, right? Just the point, okay? Just the x and y, right? The x and the y, right? Of this point. Remember that x and y are inverted, right? This point, and we don't have a weight yet, like this doesn't have mass yet, so we won't worry about that for now. But then mass, gravity, and all that stuff, we can add that later, right? But right now, just a point. Now, this is later on inherited by the circle. The circle is what gives it a shape, okay? This is what gives us the geometrical properties for the collision, okay? So that's why if we end up making a square here, it will be a different child of entity. So I might just call it rectangle, because, we call it a rectangle, right? What does this guy have? So this guy has the shape, and the size. This guy has the shape. Remember that we have like those three properties: position, size, shape, right? These guys contain the two latter, right? So uh, yeah, so we're basically gonna define them, and like all the geometrical properties come from there. So let's take a look at that. So and I think I already defined most of that in the last one, just for the circle. So remember, and what does that mean, right? And I don't think you were here for that one, Ezra. But so think about this. We're going to define collisions, right? You have two circles, right? There's a very efficient way to tell how if these circles are touching.
Yeah.
What do you think that was it?
Yeah.
Oh, no, okay, yeah. Anyway, you were here, so right? It's the difference between these two, right?
Yeah.
That the difference between these two, you have this line and this line. How do you get this line?
Not hypotenuse.
What's that?
The hypotenuse you're trying to.
The hypotenuse, right? Yeah, the h, right? You get the h, the hypotenuse, and then you also have the radius, which is this length, and then you have this radius, which is right. You have this radius, and if this total sum of these two lines, we'll call them R1 and R2, right? R1 plus R2 is smaller than the H, then they're touching, right? That's the simple test that we're going to do. That's the simple collision test we're going to do. So that's pretty simple. Now, the thing that I want to focus on is the multiple bodies algorithm, okay? So it becomes pretty apparent once we graph it, but it won't be so apparent once we have to program it. It's harder on the programming side, it's easier on the visual side because you can just see it. And you can see the solution by seeing it. And I'm going to show you how to do the algorithm, but it is going to be simple when I explain it here, harder when we program. That's it. So, okay. So each of these guys needs to know about each other, right? So let's say agent A, agent B, agent C, agent D, agent E. Okay? So agent A needs to know about agent C, agent E, agent D, and agent B, right? If we perform this test, A knows about all of them. Now, agent C needs to know about everyone. Well, we'll go A, B, C. Agent B needs to know about everyone else too, right? But we have already performed the calculation between A and B, so we don't need to do that one again. So we can skip the calculation between A and B and then go straight to the calculation between C, E, and D. And now agent C needs to know about everyone, but we have already performed the calculation between AC, and CB. So we can skip these two and then just go to D, E, and now we need to do the one between D and everyone else. D has already done everyone else except between D and E. We do this last one, and we have all of the possible collisions calculated. Okay, just by skipping the one before. So now we do have to calculate. We do have to make an algorithm to actually tell which one came before that, and it will become kind of hard to do that on the programming side. But I'll try to work through it as best as I can with you guys. Okay. So yeah, so let's get to programming then. Okay, so that's what we're trying to do. All right. Oh, let me bring this down. All right. So now screen.
With the class for collision would go in it will go in entity or circle.
Is gonna go in the main function actually.
Main?
Because okay, so that's a good question actually. Good question. Actually, it I actually create a new thing just for collisions, but on we're gonna have it on the main function for the moment. But keep in mind, so this is the thing. What is the collision related to? Is it related to entity? No, because it's about many things. Is it related to circle? No, because it's about multiple circles. The only way to actually encase collisions is when you're taking into account all of the bodies that are currently present, because entity refers just about one entity, circle refers about just one circle, right? The only way that we can do this is when we go to the next layer of abstraction, which is the actual game, which is the game is basically the physical boundaries plus the bodies within those boundaries. right? So let's do that. Oh, all right. Switch this. All right. I need to get a better setup for this stuff. Okay, so we got all the way to circle yesterday. So this has this, and I believe that this just makes the thing show, and we have two balls at the moment. Okay, cool. So now we're gonna implement something to have all of our balls in one list. Okay, so let's create a list of entities. So I'm gonna create. I'm gonna call it here. I'm gonna create three circles, A, B, C. I'm gonna just duplicate this. Oh, I'm gonna create all the way out to E. Oh, come on. Am I like remedializing right now?
How many are you gonna make?
I'm making five.
5?
Yeah. A, B, C, D, E. Okay. Now I'm going to make an array, an order list with all my entities. I'm just going to call it entities equal to an array of A, comma B, comma C, comma D, comma E. Okay. All my possible entities are in this list right now. Okay. Let me run it, make sure that everything is working. Yep, they're all on the same spot. Let me just change them so they're in a slightly different spot. So I'm gonna change my X to 300 here, 400 here, 500 here. All right. Oh, also they're not updating. Okay, so I'm gonna do a quick little function here to actually make them all update. So now instead of having to call them individually here, you see that I call each ball individually. What I can do is do this. Entities dot, or I would do four.
You
Four.
update the array.
What's that?
Would you update the array?
Yes, I'm updating the array. So look, but I have to. So I need to update each item in the array. So yeah, good thing to say there. Yes. So four. I'm gonna just call them E in entities E dot update. So for each entity in the entities update that entity. So there you go. They're all there. Cool stuff. Okay, but also we want to check the collision. Okay, so how do we do that? So now we know what the collision model looks like. The collision model is just using Pythagoras, right? And we have it here. So def collision. So I have defined this collision, and here we have, yeah, I already have everything set up here. Now look how terrible this is. This is some heresy looking here thing here right here. This is horrible because I'm calling the previously called variables that I had here, like the global variables. What I'm gonna do here is send them as arguments. Okay, so I'm gonna call here body A, comma, body A, comma, body B. Okay. Uh-huh. And now I'm gonna switch. So delta X is gonna be, instead of snake, is gonna be body A, right? Body B. Body B. Body A. Body B. So now this is a general function, okay? This function does not work just for one thing. It works for anything that I end up sending this algorithm towards, right? I got math square. Yeah, and in here I can have a consequence. Okay, so let's add one extra thing. Add one extra thing so we can actually identify who is touching who. Uh, I'm gonna add that to entity. Yeah, I'm gonna give entity an identifier, an ID here. So the last thing that you said, so we're gonna have to do a couple of things here. Just this is just so we can tell who touched who. Okay. So I'm going to after screen, I'm gonna add an ID. So everything will have an ID. Uh-huh. And then self dot ID equal ID. We do that in is that correct? Why is this? Uh, call it ID with capitals because to maybe ID is a reserved word. Uh, that seems like it might be a reserved word too. Ident, ident. I'm gonna call it ident for identification. Ident. There you go. So ident and ident. I choose these words like this because when it's a different color, that is maybe it is, maybe it's not, but it's just maybe it is the VS Code compiler telling me that that might be a reserved word. So like a word that is built into either Python or some library for something else. So I'm just gonna stay away from it. So yeah, and okay, but keep in mind that since I have added to the constructor here, I also have to send it to the, I have to send it through the child function, okay? So I need to set ident here as my last thing and in here as my last thing, ident, okay? This is not the best way to do it, but it's just what I'm doing for now. So as my last argument, I'm gonna send basically a name. I'm gonna give each of them a name. Uh-huh. You go there, you go there. Right now they're all called A, so now I'm gonna switch to their name. B, C, D, E, M, L, C. Okay? They all have their identifiers now. Okay, so now if they touch, instead of making them actually do something, I'm gonna just say print body, comma, say plus is for concatenation, body A. So body A dot ident touching body body plus body B dot ident. Right? So this is just for me to signal to myself if one body is touching another body and I can know the names of each of those bodies, right? Okay, so this looks, I think this is fine. Okay, so now we have to figure out how and where we are going to call this function because we need to call this function, right? And this function requires us to send two uh, two bodies. Okay, how do we decide what bodies to send? Now here is where it becomes kind of like hard to really do in programming or if you don't know how to do it, it becomes a little bit harder. Let me just okay, hold on. What is this? Uh, there we go. Wait.
Do you have to import the math?
The math? Oh yeah, you do. You gotta import the math to do
I
the.
mean,
Hmm?
yeah, you imported from me, right?
I imported math. I imported it up here, so import math at the top.
Yeah.
That's it.
So math dot square root.
Yes. So oh yeah, this is us getting the hypotenuse, right? The square root of the squares of the two
Right.
cathets,
Yeah.
right? Yep. That gives us that. Now, okay, so let me just configure this real quick, and I'm gonna shut the video for a second, and I'll explain what what I'm gonna do here. Okay, so I actually have not done this on Python, so it's gonna might take a little bit of doing to figure out what we're gonna do. but I'm just gonna show you like the dumb way to do it, and I'm gonna do that way first, and you're gonna see how this is gonna be pretty slow, and you're gonna notice why it's pretty slow. Okay, and I'm gonna show you by showing you why in the circles it was so nice and why it's so bad otherwise. Actually, yeah, let me draw the circle again. Okay, so we have A, B, C, D, and E. Okay, the amount of computations that I need to optimally make is all of the lines that I drew. So let's count them. Okay, so 1, 2, 3, 4. So 4 plus, okay, 1, 2, 3 plus 3, 1, 2 plus 2 plus 1, 6, yeah, 10. So this is 10 calculations I have to do. Okay, that's my optimal way. Okay, what is the dumb non-optimal way that I'm gonna do first because it's the easier way to do it programming. So I have my list here, and I want to see if you guys can come up with how you would do it programmingly. Okay, but I'm just gonna do it the way that I did it first, and then I was like, stick. Okay, so first I do, okay, I have object A. Now object A, I need to check with every other object. So A is going to check with A, B, C, D, and E. So that gives me 5 calculations here. Now I need to calculate with, and just remember that this one gave us 10 calcs, I'll just say 10 calculations. So B, I need to calculate with A, B, C, D, E, gives me 5. Then I C, I need to calculate with A, B, C, D, E, extra 5. D, I'll calculate with A, B, C, D, E, plus extra 5. Then I have E, A, B, C, D, E, extra 5. Oh, extra 5, 5, 5, 5, 5. How much is this? This is 25, right?
Want to be 16.
What's that?
Want to be 16 because you're including, for instance, A, you're including A, B is including B to look for, but it wouldn't need to check itself for collision.
You think this
Yeah.
is
So A plus B, C, and D need not A. And then B plus A, and then you take out B, and then you do C, D, E.
I don't, okay.
You're trying to make calculations for 25. I'm saying it should be 16 because you should disclude the one that's checking for the other ones.
But you need one to check with the others, right?
No, but you need a C to check C.
So, for example, no, of course not. But how would you do that? Because on programming, I'm going to show you what this is. I'm just showing you what it's going to look like because without any like more algorithm knowledge, you're going to do this. Okay, you're going to see why it's this. Okay, I'm gonna show you right now. Okay, because this is the way that like you just start, and you're going to be like, okay, I'm gonna just do this, and it's not going to look like this, but this is what's going to end up doing. Okay, so this one gives me 25. Okay, when I should ultimately when I can optimally do 10. Okay, so that is 150 percent increase on calculations. So this one is 150 more inefficient than this one, or this one is 150 more efficient than that one. Okay, so bad. Okay, and this is just with 5. Okay, keep thinking that this expands. Okay, so in the next one it's even more than that. Okay, because each time that you add a layer, it adds a layer to that layer, right? So so now let's see what we do now, because you see, okay, for example, you just saw, right, that in the algorithm, right, to check to actually to update all the balls, right? I had to put them on a array, and all the array had to check the array, right? Now let me show you what I'm gonna do after now. So go back to the screen. Okay. So okay, I have checked the entities, right? So I'm gonna do that after, actually the update comes after you do the collision. So now for T in entities, so that's the target, I'm going to collision, and I'm going to send entities E, comma, entities. Oh, sorry, my bad. No, thank you. All right, so I'm gonna go that from the top. Okay, so what I'm going to do now, me as a dumbass, I'm going to do this for T, that's targets in entities. Okay, I'm going to do collision, and I'm going to send entities E, comma, entities T. Oh, and I didn't post this on any of the. Oh, hold up. I forgot. I forgot. What the? What? Wait, hold up.
They're going to kick you out.
I do not know what that is. Let me check that out real quick. What the hell? Oh, okay, no. That's, I am glad that she was. Oh, okay. Jesus Christ. Oh, wait, it's disrupt. That was bad. Okay, guys, listen, we just make jokes sometimes. That's not good. No. Okay, guys, there's you guys didn't see. Stop it. Okay, listen, guys.
You're liberal.
Jesus. How do I get rid of it on the stream? Uh,
It's both once on.
no, the thing is, I need to send this thing.
Oh.
No, it's not good.
I don't even know what that is. It's like I agree with whatever
You know, whatever Stephanie says, we agree with. Okay, we.
that.
Oh my God. Oh, there you go. Okay, now we're done with that. Okay, enough memes. Jesus. Okay. All right. Okay. Okay. So, okay. So if you see what I'm doing here, right? I'm checking the collision, right? And this will work. Okay, this is going to work. And I'm also updating the entities. So, oh yeah, I'm checking the collision, and then after I check the collision, I'm updating the entities, right? That is okay. Okay, but as you can see, this is doing 25 calculations per 60th of a second. So might become pretty slow. It will work. Or no, list indices must be integers, slices, circles. E is not a circle. Oh, okay. Sorry. So I have to do. This is not an index. Okay, let me. Uh, array by index Python. I don't know what to do with NumPy. You think I'm gonna download a library right now? Tripping, brother. There's a better way to do it. For loop Python. I always forget how to do this because I don't know why. I don't know. Python is just I just like to be all quirky, and no one does it like this, but okay.
For X and range.
Yeah. So whatever. So for what is it? For E in range entities dot length. Dot length. Dot length. Length. Jesus. All right. For range entities dot length length. Jesus, I'm so retarded. Length. Actually, no. What am I doing? Oh, my bad. Okay. Actually, I just remember that I'm doing this so stupidly. Instead of doing that, I can just do this. E comma T. There you go. Oh, there you go. This should work. Rad. Oh, yes, it is the radius. Oh, of course. So let's. How did I define radius here? Just radius. So instead of, I have to change my method here a little bit. So radius times 2, it would be body A dot radius plus body B dot body B dot radius. All right, let's check it. All right, and looks like I am okay. Let me.
Looks like they're touching.
There. Yeah, I think that there's a mistake there somehow, some way, somehow. Let me add this. So it says body E. So yeah, they are, it looks like they're all touching. This might be because they're too close to each other. Let us decrease their. Should I decrease their size? Yeah, let's decrease their. Well, I'm gonna just increase the separation. Uh, put. Uh-huh. This might not be an accurate representation. More think about it, but fixing that is gonna take it's gonna take some doing. Okay. Let's try just like this, or maybe something's wrong with code. Who knows? You know. 6, 7, 8, 9. Let's try this. Let's separate them a little bit more. They should not be touching. No, it looks like they are touching. Things that they're, but they're not touching. Let us see. So body A position 0, body X, this delta Y delta X, square root, indent. Okay, so let's try to reduce the amount of bodies for a bit. So now we just have, see, it says that A is touching B. It looks like a logic error here. So if H is smaller than the radius plus radius, uh, let me print the H, print H, because I remember H was accurate before. So let's see how much H it has, and let me print. I mean, this is probably going to be, so this is, I know this is 100 because all of their things is that. There's 100, and is there a, oh, is there a 100 difference here? There should be a 100 difference on X. Yeah. Let's print out the H. Let's see what happens. As always, you got to do a little bit of debugging on when you're doing them. So it says 2. Says that my H. What the heck? Hold on, let's stop this. Take a look. So it says that, oh, it's saying that, oh, look, I'm getting the calculation that my H is 0 sometimes. How can that be? So delta X times delta X. Mm,
That makes no sense.
maybe yes, maybe not. Well, let's think about it. Let's try to figure out why this happened. So there is a difference here when checking one with one and the other. Oh, yeah. Wait, okay, is the I think that okay, so I know what's happening is that when one checks with the other, yeah, that makes sense. Okay, so how do I solve this? Just let me think for 1 second. Uh-huh, uh-huh, uh-huh. Okay, so actually, well, let me explain. I don't want to just like be like pontificating right now, is because I know what the mistake is. So it's a math error. So what is the math error that I currently have done? Oh, so or not math error. So what happens here, right, is that I'm checking one against the other and the other against the other, right? And one of them at some point is bigger than the other one, right? And they switch basically. So they give me at some point you have this bigger value against the smaller value. So it gives me like a minus value here. And well, actually, no, let me think. Actually, no. They should always give me. Let me see. Let me check. So let's see. My stock
I
printing.
mean, Pythagoras theorem, isn't it subtracting in the square root?
If you're subtracting, if you're trying to find the catet, but I'm trying to find the hypotenuse. The
Right.
hypotenuse is the sum, right? So let's print out delta x and delta y. See what I did wrong. Delta x. Print out delta x. Print out delta y. Let's see what I get here. All right. So, oh, so for some reason I get
0.
I get 0 here.
Negative.
That makes sense. Yeah, it makes sense that I would get 0 delta y because the y is basically the exact same for both. But okay, so let me check that. Let me just say here, I have to do a little extra method here to make this a string. So str, just so I can know exactly what I'm getting here, plus, so this is x is this, then
STR string.
yeah, that's to transform the integer to a string. Yeah. Plus str. So, everyone ends up bugging like this. I mean, if you have like 10,000 years of experience. Okay, so let's see what we get. Okay, so this gives us some insights. So, for example, you see that I'm doing 3 calculations per time, and then it's telling me if the bodies are touching. So, well, look, this tells a kind of an interesting story. You see? So, in here I have that while the delta x is minus 200, right? Then the calculation gets performed and they're 200 apart, basically. They say that you're 200 apart on x, so you're not touching, right? Then it does the calculation again. It says that you're 200 apart on x again, and it's interesting, right? You get the minus because that is the difference between the minus would be the one further to the right from the one further to the left. That gives you minus 200 because the difference between this one and this one is minus 200x, right? And it says you are 200x apart, you're not touching, right? Then it does it with the next one. It does it from the first one, the one further to the left to the one to the right, and then you says you guys are 200 apart, you're not touching. But then we got this interesting one here that this says that this is 0. So x
Wait, is it searching for itself?
searching for itself.
Like when we talk about
Oh, you are correct. Exactly. The difference between it and itself. And and look at Ezra, you're a genius. Look at that. Yeah, look at that. Body B is touching body B. Good job. Okay, so yeah, he has it. Yeah. So now we need to make an exception for that. Amazing. No, good catch. So now we need to make an exception. So how do we make it so that we never are using the same body? Uh, so that we never are checking the body itself against itself. So I could make a cop out here and say basically
self.
I mean, yeah. For example, I could do uh, if body A dot ident is equal to body B dot ident return. This should exit the function. Okay, yeah. If they are the same body, then we just return and then we don't do anything. So let's try that. But you see, we had to do a little bit of detective work. But yes, Ezra, you were right. Good, good. So, and there we go. Not touching anymore. Perfect.
Yeah.
All right. So Yeah, so that's how you just do detective work. That's how a lot of this stuff is. So cool. Now let's add the rest of the bodies. Okay. Uh, now it's gonna start to slow down. So C, D, E. Oh, comes this guy. There we go. And nicely enough, none of them are touching. Perfect. Okay, so now I need to one of them agency. So I'm not sure if any of those methods work right now. So I'm just gonna make them touch by them falling to each other. Okay. So I'm going to put them on the same x-axis. Uh-huh. So x-axis is gonna be the same here, 100, and I'm gonna just put this one higher. So this one is going to be on the 50s, and this one is going to be on the 150s, not 150s. Actually, this one's going to be on 0, and this one's going to be on the 100. No, 1100. Okay, so we're going to go. And we have a bit of an error there, says that they're continuously touching. That might be because they might be because the geometry is not correct, or it might be because the images don't reflect exactly how the images do not reflect exactly how big the ball is. So the ball itself might be bigger. So let me just look up real quick how to do the circle method from Pygame. There must be a circle. Uh, Pygame draw circle method. How to draw circle Pygame.
No, that's how to literally draw it.
No, yeah, I wanna draw it
Oh,
here. So draw circle, get pause. Pygame, draw circle, screen blue position 20. Why am I looking at this thing? I want to get it from demand themselves. Polygon, draw circle. Perfect. Is it from? Please tell me it's from the center and not from somewhere else. Surface vector center. So center radius. Perfect. Okay. And uh center. Oh, of course, yeah. So center's a vector as it should be. So we are not going to use the ball for now. The when we draw it, we're gonna evade this method for now, and we're just gonna draw it as a circle as it should be. The thing is that what happens here is that I believe that that the pixels of the picture, because of the way that we are using them here, like that we are scaling them, they do not appear as they should. So let's do self dot screen dot blit no dot what is it called, self dot, or is it draw, pygame dot draw. uh Maybe I do need that guy. Let me look. Oh, how do we do this? See, pygame draw circle screen. Oh, okay. There you go. So we go do something like this. Pygame dot draw draw circle. Okay, the surface we send the self dot screen, comma. Is that correct? Uh, I will just do blue for all of them. Position is going to be self dot pause, and radius is just going to be self dot radius. All right, this is going to give us a more accurate look at the balls. Then we can deal with the scaling issue later. Blue is not defined. Hear me? Let's just then can I just do blue as a string? Blue, not there. There we go. And oh, I see what's going on. They were just separated just by 100. You see, And because that's just the scaling effect, right? So now let me separate them by a little bit more. And I should have known this. Actually, yeah, look at that. I should have just known this. So if I make this guy go a little bit further down, then they won't be touching for the beginning, I believe. So, oh, and I just made a start for no reason. Uh-huh. And then they're touching. Look at that. So with that, we have confirmed that our stuff works. So it works. But as you know, it's painfully bad. Okay. So let's see how much I can push it until it breaks. Okay. So I'm gonna try to break it right now. So and this is pretty simple. Okay. So E. So we're E F G L M.
HRJK.
I just skipped that, dude. Son,
A,
I have my own artistic license on the ABC.
Yeah.
It is an artistic
Yeah, your
license.
own album.
Exactly. Oh. So let's see how many of these guys we can add until it breaks. So E, we're gonna do F, C, still kind of working, yeah. F, G, D, still working, not bad, not bad. L, and remember that the just keep growing and growing as we keep going. No, pretty impressed, pretty impressed. I have a decently good PC. I might just, you know, might be able to keep this up for a while.
This
Mm, okay, yeah, no, this might be a battle. I cannot win easily. So let's actually, okay, I'm gonna do a method to actually make this easier. So make another. Uh, so I'm gonna do so we can make this easier. Uh-huh. Grab one of you guys. Ba 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 ba. Uh-huh, uh-huh, uh-huh. I need a circle. I need to put it inside of these entities. So I should make an so let me see how to add items to this Python. What's the method? So append. There you go. Append. Need to do append. So entities equal that. Uh, for I what is this? Oh, as what happens if you don't remember all the things. For I in range. In range. I'm gonna go for 10 items. Entities dot append and uh-huh. And then I'm gonna name them. I'm just gonna name them I. They're gonna be named by whatever thing they have. Put this on line 100. Pen, start penning stuff. So I'm doing this with 10 items there. Did I do something wrong here? An int. Str. Turn it into string. There you go. There identified now. There you go. So still working. So let's go to 20. Okay, let's go with 20. 30. Yeah, 20 items. Yeah, let's go with 20. Oh, it's starting to struggle. Oh, it's starting to struggle. Oh, look at it. Oh, my computer's going down. Oh, look at it. Let's go to 30 items. And there you go. We have finally gotten to the limit of of what is. So we could actually do a calculation how many I believe there's a way to calculate this. I forget the math way to do it, but basically, yeah, there's a way that we can put all the calculation numbers. Actually, no, actually we can do this. It's not that hard, I think. We just, yeah, 30 by 30. Yeah. So nine 900 calculations.
Just
So we're doing this.
calculations a second.
Yeah, no, 900 calculations every 60th of a second.
Oh,
So every second is 900 times 60. So calculator, so yeah, 900 times,
54,000.
yeah, 54,000. Yep, there you go. So 54,000 calculations every second, okay? Yeah, so now so you see, and but now think about that, okay? The games and things that we play, or like any physics engine worth its salt, has not just 30 items inside of it, it has thousands of items inside of it, right? And we know that, and this is not like a linear relationship, that I told you that like for 5 items using the other algorithm was 150 times faster, right? The more you expand, it does not increase linearly, it increases quadratically, right? So basically that the more items you have, the as it's a quadratic curve, it's not just going to be 150 times faster, it's going to go to like thousands of time, right? So it's going to become more and more efficient the more items we have, okay? So, and it becomes basically actually inverse. It becomes, so if you're seeing logarithms, so it goes from being like in and it goes from being like the amount of calculations that you do are basically quadratic, right? They become logarithmic, the inverse. So the more calculations you have at the end tail, you have to do even less calculations, because if you do mostly calculations at the beginning, right? Because you see that A has to calculate against everyone else, and then but then B doesn't have to go with A, and then C doesn't have to go with A and B, right? So the more calculations you do, the more you reduce the calculations at the end of the cycle, right? So that's a concept. I mean, the concept that everyone that is doing computer science should know is big O station, yeah, big O, and you can see this explained here by a graph. So take a look. So basically, we right now are here, and this is the unacceptable. Like this is the horrible. So we are n to the n squared. Okay. So our calculations, the number of items that we have, increase our calculations quadratically. Horrible, right? But then when we do it right, then we will are gonna be on the logarithmic one, which is the super nice one. Okay. So what I would say is you guys go ahead, try to do it. Try to see if you can find a way to. Well, I already told you what it is, right? You have to skip the one previous, but now how do you actually put that into code? Okay, so that's the harder part. So or maybe you'll just figure it out. But the thing that is more complex is that you know what to do, right? You know that you need to skip for every time that you go forward on the list checking, you need to skip the previous one. And actually, when you do this one, for example, the thing you said and the thing that we just implemented here now, that disappears, because if you have a function that skips the one previous, it also skips yourself. So yeah, so that's it. So we'll do that next class. Okay.
So as it stores the previous calculations, but we just don't use them when doing it, how I'm doing it right now.
Start the previous calculations. What do you mean by that?
So we calculated for circle A.
Hold on, let me
B,
put
C, and
this.
D, and E.
Let me put this here real quick. So let's see. Let me cancel this out. So 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 I can try to see what you mean.
isn't there? So sorry. You can go.
Okay, so for A, right, you can see that we calculated C, B, D, and E. Is that stored on the computer when we're doing the calculations like that, the one over there? Or does it and it restarts doing more calculations?
So by store, the thing is that is an interesting thing that you're saying, because we're not storing anything. Okay, we're doing the calculation, we're replying to what the calculation outcome was, and then we forget about it. Okay, for this one and for this one. Okay, memory is a very small concern here, but I mean, think about the thing is that now think about what you said, which is an interesting thing that you say is that now this is just amount of calculations, right? But let's say that we were for some reason saving them.
That was great.
So the amount of memory space basically is you have to grab this whole thing, and then do it again and store it. You actually have to then after you did this, then you have to write it somewhere in the disk. You write it somewhere in your memory, and then you go again, and then you write that part into the disk. The chunks are crazy, but there that does happen. You do that, for example, in very complex like rocket, for example, rocket applications. There's these chunks of data as your rocket is going up because you want to get all the chunks of data that you want. You grab all that data and you write it somewhere and you send it back in case the rocket blows up. You can know why it blew up. Or I mean, no, we don't need to go that far, but like for example, I went to the Formula when this happened here in Miami. I went to the Formula One, like to the Mercedes Benz, their their garage,
Yeah.
and I was very actually because I do a lot of network development. I was interested in how they were handling like the data that they collect from the cars because their thing is all about like when you are. This is not like a commercial car. This is like the highest of the high performance cars you can have, right? And in order to win their competitions, they need to get the performance as high as they can. So they need to collect all that data and see, okay, so because of the drift on this point of the track, we can improve its performance by 2% by adding this piece of weight on this other side. Like that, those calculations do get made, you know? So they basically, what they have to do is basically they have to collect all the data from all their sensors, put in a chunk of data like this, pack it and send it to a server so the server can like save it somewhere because those cards also can blow up, right? Or like send it to a black box, right? When you talk about the black box on airplanes too,
Yeah.
what is the black box doing is basically grabbing all the calculations that are done and storing them somewhere, right? That is a concern that I'm interested in you thinking about it, but we are not thinking about that at all right now. That's a whole different thing. But yes,
So the code that we're gonna do is it's gonna hold the previous information for a little bit just to make its new calculation.
what for example for in our case here, so what's going to happen is like every frame something's going to like we're going to do the calculations for like all this like these things that get stored are for example the position and the velocity of each of these balls, right? So let's say that these balls collide at some point, right? That these balls collide with these balls, right? Okay, they collide, and now the only thing that we're storing is the change in velocity that resulted from this collision. So these just resulted in a collision, right? These guys collided. We calculated that they collided, and we want to make them like go in separate ways, right? So you could say, I'm gonna do like a little storyboard here, okay? On this point, right? They have like their velocity that is saved within their bodies. They have a velocity that is sending them on this direction, right? When they touch, they still have that saved on their memory. That like their velocity is sending them this way, right? The only change we do in their memory, right, is that now the arrows point in different directions. That's that's the saved storage. That's the only thing we do to like the storage devices that we have created, and those are the classes, right? But apart from that, those calculations get done and they get tossed in the trash. Okay, because we're checking if something's touching, and most of the time things are not touching, right? Like, or I mean, I'm not gonna get philosophical about it, but like, yeah, most of the time, for our purposes, we do the calculations and nothing happens. Okay, but we need to know if something happens. Most of these calculations get tossed. This that thing gets calculated, tossed, and gets calculated and tossed 60 times a second. Okay, important to know that, right? So I mean, and it would be the same. Like, for example, if I want, I mean, and two, it would be easier for me to just save these 10 calculations than those 25 calculations if I wanted to save them for some reason. right? When I printed them, that's just the computer printing stuff up and spitting them out, and then forgets about it, basically. Like, or at least this program forgets about it. Some program needs to remember them so they display on the screen, but this program forgets about
How are we gonna code? Like, how does the computer use the previous, that it compiled with the collisions in order to, for instance, you want it, well, the idea is to remember A and B's placements. D knows A and B's placements, but you're taking it from doing the calculation of A and B and like setting them to C rather than rechecking for both of them. Does that make sense?
it. Okay, can you say that again, sorry?
So we at first calculated the positions of all the other ones compared to A. And then we took A and B's calculation and put it to C. So it knows the placements.
Oh, I think I know what you mean. Let me see if I let me see if I understand what you're saying. Okay, is that okay? Let's go from this, right?
Yeah.
You're saying that, right? When I perform my first set of calculations, when I did A to B to C to D to E, right? Right? In order for me to do my B calculations, right? B needs to know about the A calculations, right?
Yeah.
Yes and no. Okay? B does not know about the A calculations, but I know that I already know B calculations. And I already know that, or like the higher program already knows about that A performance calculations and already did all the adjustments based on the A calculations. So we can ignore these calculations here. So basically, we're ignoring an extra set of calculations because from a higher perspective, we already know that set of calculations. We are not recording them. We're not doing like in a. I understand what you mean. The in a in a sort of, let's think about it in a how you say not hypothetical sense, right?
Yeah.
Right. So let's say that for some reason these three items are calculating are colliding at the same time.
Yeah.
Okay. So this is A, this is B, and this is C, right? This is C. So this guy collide against this guy collide against this guy, right? So A already told C and B what they're now. Now, okay, so now that just one thing to keep in mind is that the update happens after the collisions, right? So what happens here? So basically, we're doing the collisions here, right?
Yeah.
We're doing the collisions, and people do this. This what you're describing is how they like handle the effects of the collisions. That happens after though. That happens on the update, right? On the update. Okay. So now this thing happened, right? So this is giving this guy an impulse down here, right? And an impulse over here, right? So because of these collisions, right?
Yeah.
And this guy is getting an impulse this way and this way, and then you do vector, you sum up all the vectors in order to tell like what the result is at the end. I'll explain that we can get into later, right? But then when I'm doing this one, I already know all the resulting vectors from here. You see, I know this guy, this vector, and I know this vector. So I can ignore doing this calculation again, and then I can just focus on this collision. So then I get the vectors from here, I get this vector here, and this vector here, and the sum of this is going to give me a vector like that, it's going to give me a vector like that, it's going to give me a vector like that in the middle of them. Okay? So that is done after the fact. So there is, and that what you're thinking about, that is like uh, that is defined in how you do the architecture after. But yes, you are in a good direction for what you're thinking. But the thing is that you you don't store it. I mean, you store, for example, like you could be like if you get into when you get into physics, right? Like the impulses done are the sum of the forces, right? So like there's forces and you sum them up and that's going to give you the acceleration, right? So you need to store them up and that, but there's easier ways to do it. But like for like the more accurate models, you do have to do it that way. We can get into that later, but yes, It's a good question. Yeah. Well, we'll get into it after. But good. All right, that was amazing. Yeah, good stuff, guys. Yeah.
Is there a logarithm module in Python? Like if you
So you
input
guys know.
Okay. Logarithm module
yeah like log
in math I believe so. You can do the
you can technically
you can
uh,
no you cannot just